Good morning. So last week we had studied about single step matching and what we had studied. So let's just revise it again. So we had a load impedance connected here and we had a stub in parallel. And for example, we had considered a short circuit stub. So I'll directly go in terms of Smith chart. So this was 1 plus J0 characteristic impedance in normalized form. And since this was in parallel, again I repeat, these two are in parallel. That's why we consider G plus JB, which is what? YL bar. That is in normalized form. So what we want to match G plus JB to 1 plus J0. So what we do? This is the load side. This is which side? Generator side. So what we do? We start from YL bar. Actually what is given? ZL bar is given. So we plot ZL bar. Then we draw a VSWR circle. Then we take the diametrically opposite point of ZL bar, which comes out to be YL bar. So we have got YL bar now. So what we do? We have to make YL bar, that is G plus JB, to 1 plus J0. So what is our first step or first concern? To make G somehow 1. So how can we make that 1? We'll move. This is what? A transmission line. So we move along the transmission line a length L1 such that this G becomes 1. And since we are moving along the transmission line, we have studied in doubly transmission lines chapter that impedance as well as the reactance will change, or to be strictly speaking, admittance and susceptance will change. So G, we stop on the VSWR circle such that G becomes 1 and B will obviously become something J prime. Now what is our next step? We have got 1 plus JB prime. So half of the work is done. What do we have to do? We want 1 plus J0. So how will 1 plus JB prime become 1 plus J0? Just subtract minus JB prime. So we'll connect a stub such that it is minus JB prime. Right? So 1 plus JB prime minus JB prime will give us 1 plus J0. If such is the case that this is 1 minus JB prime you get, it might happen. What you will do? You will connect 1 plus JB prime. That is, the stub will act as an inductor. In this case, stub is acting as a capacitor. Okay. So this is the way we solve. Now next is single stub matching, but this was connected in parallel. Now we have in series. So we are having it in series now. So what should be the changes? Let's say it is again short circuit. So what should be the changes? This will be 1 plus J0 as it is. But since this is in series, we can keep it as R plus Jx only, corresponding to ZL bar. Why was this done as YL bar? Because it was in parallel. Admittances are directly added in parallel, but resistances are directly added in series, so no need to convert to YL bar. So just take ZL bar. Next step is what? Same thing you have to do. Only the steps are less here. So see, this is actually simpler. So ZL, start from ZL bar. You are moving away from the load, that is towards the generator, that is clockwise on the Smith chart. Move a length L1 such that R becomes 1. So what to get? 1 plus Jx prime, for example. So you have got 1 plus Jx prime. Like this, half of the work is done. So you have to remove this Jx prime. So what you will do? You will connect minus Jx bar. And it was in parallel before, now it will be in series. That is the only difference. Okay. So let's see a sum based on this. Again, this is a solved example in POSAR. So the question is, match a load impedance of ZL equal to 100 plus J80 ohms to a 50 ohm line using a single series open circuit stub. Remember, last time we had seen short circuit stub. Here also I explained short circuit stub. Instead of short circuit, we are having open circuit. So let's see how to solve that. Assume that the load is to be matched at 2 gigahertz. So frequency is given. So what is the first step? To find ZL bar, because we are plotting on the Smith chart. So ZL bar is ZL upon Z0. Therefore ZL equal to 100 plus 80. You should be in complex mode. 100 plus 80I divided by 50. Again, if impedance is not given in the exam, you assume it to be 50 and clearly mention that it is 50. That is you are assuming. So 2 plus J 1.6 is the ZL bar. ZL bar. So what is the first step? To plot on the Smith chart ZL bar. So ZL bar is what? 2 plus J 1.6. So this is my 2, R equal to 2 circle plus j, so I'll be on the above part of the Smith chart. So j 1.6 is, this is 1, 1.2, 1.4, 1.6. So here, and this will be my 2. So this is my point. What is this? ZL bar. Next, what we have to do? We have to draw a constant resistance circle. Sorry, a constant VSWR circle corresponding to this ZL bar. So with the center and ZL bar as radius, draw a circle. So I'll use a blue pen to highlight the circle. No need to draw this with pen in the exam. Just plot point ZL bar you draw, and you write ZL bar with pen if you want. So what is the next step? If it was a parallel stub, you would have made what? YL bar, diametrically opposite point, but no need to do that here. So what will we do? You can understand from this diagram. So always draw this diagram. It will make life simple for you. So from ZL bar, we are moving away from the load. So we'll move towards generator. So here it is written towards generator. So towards generator means we'll move clockwise, means in the downward direction, and move along the constant VSWR circle such that R becomes equal to 1. You are not concerned about reactance. Right? So I'll use a green pen now. So I am here. I am moving. Where is R equal to 1? Over here. Right? So I'll move like this till I meet R equal to 1. So I'm moving in this direction. So you draw this arrow, and from this point to this point you draw with pen. Yeah, till here. This is the point. Next, what we have to do? And this corresponds to some reactance. So this reactance I am getting as minus J 1.3. Right? So what point we have got? So see, we have got a negative point. So instead of 1 plus Jx bar, what is our point? 1 minus J 1.3. Am I correct? Yes, 1 minus J 1.3. So we require a reactance of what? Plus J 1.3. Right? So plus J 1.3 is over here. So plus J 1.3. Right? So next thing is to what? To do what? Find this L1 and this is LS. I forgot to mention while explaining. So we have to find L1, distance of the stub from the load, and stub length. And in this case, it is an open circuit stub. This is not short. This is open circuit stub. Right? So L1 will be what? Take a scale and a pencil and draw a line. So with ZL bar and center, draw a line. Then with the reactance, draw a line. So this distance will give you what? L1. So this for me is around 0.329. So 0.329 minus this is 0.208. So 0.208. So 0.121 lambda. So L1 is 0.121 lambda. Next is what? To find LS. Now for that, what you have to see? You have to see the question. It is which type of stub? Open circuit. If it is not mentioned in the exam, you can take it as short circuit or open circuit. Mention it clearly in the exam, but preferably take short circuit. Now what we did in the last lecture, last week, it was a we were considering YL bar. So we are considering as admittance Smith chart. So for admittance Smith chart, what was the short circuit? This was the short circuit. With blue pen it is impedance Smith chart. With red pen it is admittance Smith chart. So we went from here. Now it is what? Open circuit stub, and we are considering as impedance Smith chart. So this is short circuit. This is open circuit. And what we had seen last time, consider the stub as the load. So from stub you are moving here. So you are moving away from the stub, means you are moving away from the generator. Sorry, away from the load, means towards the generator. So from open circuit point you are moving away from the generator. What I mean is, this is your diagram, right? This is open circuit stub. So consider open circuit as stub, like last week. Short circuit was considered as stub. So open circuit as load. So you are moving away from the load. So you are moving towards generator. That is in clockwise direction. Where? From open circuit. So this is my open circuit. So I'll extend it here. I will move towards the generator. That is in clockwise direction. Right? So from this till here. So I want this distance. I'll draw with sketch pen. So extend this line. So till here, this distance I have to find. So this is intersecting at 0.146. So how will you find this distance? This is how much? 0.146 lambda. And we know the complete distance is lambda by 2. So half of lambda by 2 is 0.25 plus this is 0.146. So 0.146. How much I am getting? 0.146. So 0.396 lambda. So LS is how much? 0.396 lambda. Understood? This is the way you have to solve. We are not yet done. We are done on the Smith chart, but we have to draw the final circuit network. So it is an open circuit stub. So draw it like this. So this is ZL. So write ZL equal to whatever it is. What was it? 100 plus J80 ohms. What is this distance? L1. L1 we have got 0.121 lambda. What is this distance? LS. How much you have got? 0.396 lambda. Right? Make sure this is open. So here you can write open circuit. And this is the generator side. Okay, so this is the way you have to solve. What will be the second solution? What they have mentioned? They have not mentioned anything about solutions. So you can do away with one solution only. What will be the other solution? I will not solve it again. You do it for homework. That's why the videos are small in length, maximum 30 minutes. Another 30 minutes are for you to practice on the Smith chart, and this will be the trend for the whole course. So from here till here it is, I am intersecting on the R equal to 1 circle. But what if I move away, move further? So I am starting from here again, I am moving on the VSWR circle like this. I am again encountering R equal to 1 here. So I'll draw this R equal to 1 with the pen upwards. So there are 2 points, right? So one is till here, 1 point. The other is till here. Right? So this is the second solution. Right? So this will be your, so what do? You take this line, then take this line. So these two lines you take, and this distance will be, this whole distance I am saying is what? L2, because we are doing second solution, so distance is L2. So this reactance is what now? Positive. So it is around J1.3. So this will be minus J1.3, right? So again from open circuit will take, again it is what? Open circuit stub. So from open circuit till here, this distance you have to take. So this will be small. Understood? So again it is solved in Posar. So for the final answers you refer Posar. Microwave Engineering is the name of the book. It will be around page 240, 4th edition. Okay. So make sure you solve on the Smith chart. Again it is very important. And I told you, you will get at least one 10-mark question for this. Single stub matching or double stub matching. And last exam they asked 2 questions, so 20 marks. So from first module itself you can score 20 marks. And these are the sums such that if you do everything correctly, you will get score full 10 marks, since this is not theory. So if you get the correct answers, you will get complete 10 marks. So make sure you solve this and take it seriously. Thank you.